Part 3 of our video is the question of how do you rotate an image on coordinate planes? Well, this is a little bit harder, but it's not that much harder, okay? Let's just say I have like a point 3, 2, right? 3, 2. And I want a clockwise rotation of 3, 2, okay? Here's how I want you guys to start thinking about this. First off, 3, 6, 9, 12, that's the clock right there. 90-degree rotation means that this thing right here, 90 degrees clockwise, that means this is in quadrant 1, 2, 3, 4. Right now it's in quadrant 1. 90 degrees means it's going to start from here and it's going to end up going this direction, right? Well, if it's only 90 degrees, it's going to end up here. So that's the first thing. And then what type of coordinates exist over here? You have a positive and negative coordinates that exist in quadrant 4, right? And so the only thing that you really have to think about is that if it's 90 degrees, you just have to switch its position, okay? So it's 2, 3, but because it's in quadrant 4, the first number is positive, the second number is negative. So this is positive, this is negative. So positive 2, negative 3. Let's double check if I did this correctly. I'm going to connect the dots with a red pen to the origin. Yes, I did do it correctly. This is correctly a 90 degrees clockwise, okay? If it's 180 degrees clockwise, right, we'll stick with 3, 2. The thing is, it's going to probably just stay the same, 3, 2. But think about where 180 degrees would be. It's on the opposite side, right? So it's going to make a perfect straight line. So it's going to stay the same, but if you notice, it's actually going to be quadrant 3 has negative, negative as its coordinates, right? So this is actually going to be negative 3, negative 2, okay? It's a lot of using intuition. And 270 means it's all the way around, or the same thing as 270 is 90 degrees counterclockwise, okay? So 3, 2, let's just use right here. Counterclockwise means you start from this side and you go the other way. If we're going the other way, it's got to be in this quadrant right here. Now, you see this 90? 90, it means we flip, okay? We switch it. So instead of 3, 2, it's 2, 3. And then all we have to do is look at the quadrant. Quadrant 2 coordinates always have a negative and a positive, right? Negative, positive. So you make this a negative, positive. So negative 2, 3 is right there. And then here we go. Connect the dots. Bam. Okay? So here we're able to perform each one of these rotations. So how would you rotate an entire image? Well, first you got to understand like what's going on. First you need to plot these things, J, K, and L. So let's very quickly, J is 1, negative 3, K is 4, negative 1, and then L is 5, negative 5, okay? Step 1, done, having the coordinates down. Step 2, rotation 90 degrees counterclockwise. Well, 3, 6, 9, 12. If it's 90 degrees counterclockwise, that means this image is going that way into quadrant 1. And quadrant 1 has positive numbers. Also, you see 90 degrees, that tells me I gotta flip. So I'm just going to lay this down ahead of time. It's 3, 1, 1, 4, and 5, 5. And the thing about knowing which quadrant it ends up in is that they have to be both positive, right? So here it is, 3, 1, 1, 4, 5, 5. So let's try this out. 3, 1 is here, and that's J prime. 1, 4 is up here, and that's K prime. And then 5, 5 is up here, and that's L prime. And let's connect the dots. Let's see. Bam. Notice that the size and the shape of JKL has not changed. It's just been rotated. And how has it been rotated? Exactly 90 degrees counterclockwise. And if you still don't believe me, what's the one test for us to check? All we have to do is connect to the origin, right? So K connected to the origin, and then K prime connected to the origin. And as you can see, this image has been rotated 90 degrees counterclockwise.